Good morning, my dear students. I already teach about that Henry law in our last video. So, today we are going to talk about some more about this Henry law. Okay, so we already learned that Henry law is defined as P equal KH X. Okay, so if we can write it like P equal P into 1 by X equal KH, we should write it like this. Okay, so what happened? So KH is inversely proportional to 1 by X, and X means that mole fraction. Okay, so that KH is the Henry constant and X is the mole fraction. So whenever KH since KH is inversely proportional to that mole fraction, so what happens whenever KH is increased, mole fraction is decreased, and whenever KH is decreased, mole fraction is increased. Okay, so here we have some important note about here that that higher sorry the higher the value of k's at a given pressure, lower the solubility. Okay, so we know that solubility is directly proportional to concentration. We already know about these things in our previous videos. Okay, so solubility is directly proportional to concentration, and concentration is denoted with the help of mole fraction, molarity, and all that. Okay, so whenever k's is increased, we know that mole fraction is decreased. Okay, we already learned it from that Henry law. So when in this sentence, higher the value of kh means lower the x value, means lower the solubility. Okay, so what happened that values for both N2 and O2 increase with increased temperature. Okay, when temperature is increased, then what happened, the value of N2 and O2, the value of KH in N2 and O2 increase. Okay, so with temperature, since KH is increased, what happens, solubility is obviously decrease. Okay, uh, maybe you understand my point. Okay, so with temperature, KH is increased, that means X mole fraction is decreased, that means solubility is also decreased. So those those things, I mean those who lived in that water, they they feel good to live in low temperature. So here it's that it is due to this reason that aquatic species mean those species who live in water are more comfortable in cold water. Why? Because in cold water, k's value is less. Okay, in cold water, k's value of N2 and O2 is less. So what happened, X is increased, that means mole fraction increase, that means solubility increase. So since there are more number of gases are soluble in water, so those aquatic species feel good to live there with more amount of oxygen. Okay, because we know that species mostly need oxygen to live, oxygen and nitrogen. Okay, so here okay, we learn about this thing. Okay, and here a graph, and this graph is about, here we take that pressure, sorry, here we take that pressure, and here it's that x. So from this equation we are going to create this graph, and since it seems like that, y equal mx plus c, here c is 0. Okay, so we know that the equation for this in graph, we get a straight line, something like this. Okay, so this graph is like this, that's why this graph is a straight line. Okay, because this equation is same like as y equal mx plus c. We learn about these things in our mathematics. In mathematics we learn these things. Okay, so after that, there's an important example. We have to understand this because it's important for our examination point of view. Let's see the question first. That if N2 gas is bubbled through water at 293 Kelvin, how many millimoles? We have to calculate the moles. Okay, and please please underline it. I mean, we have to calculate in terms of millimoles, not in terms of moles only. Okay, if you are going to complete this equation and then you get the answers in mole and you forget that you have to uh, find this answer in millimoles, then it will if affected you. So just remember those things, that in which unit you have to give the answer. Okay, then after that we dissolve 1 liter of water, and here given that the water is 1 liter, and assume that, and to exert a partial pressure, here partial pressure value is given, and Henry law constant is also given there. So we know that if we have to calculate the mole, first of all we know about that p value and kh value, so we can calculate x very easily from here. Why? Because p equal kh x. Okay, so x equal p by kh. Okay, so here this equation is used. Okay, so here you see that x equal p by kh. Okay, so we put the value of p and kh and we get the value of x. Okay, so we get the value of x, which is mole fraction. Okay, x, which is mole fraction, and we know that x equal x equal Na divided by Na plus Nb. We know about that. Okay, so here Na is the mole of nitrogen and Nb is the water, because nitrogen is dissolved in water. Okay, so we have to calculate that Na, I mean a mole of nitrogen. We have to calculate that mole of nitrogen here. Okay, and mole of water is 55.5 mole. How we come to know about that 1 liter of water contains 55.5 mole of it? You have to know it. Okay, and if you want to know that how you get this, so wait a second, I am going to explain it to you. Okay, so we know that there's 1 liter of water is given. That means 1000 ml. Okay, so here we know that density equal give mass by volume. Volume is 1000 liter and density is 1 gram per mole. 1 gram per ml. So if we calculate, if we have to calculate that mass equal density into mass equal density into uh, volume. Okay, so density is 1 and the volume is 1000 ml, so we get the gram in 1000 gram. Okay, so we get that gram. Now we know that number of mole equal given mass by molar mass. Given mass is 1000 gram and molar mass is 18 gram per mole. Okay, so if we calculate these two, then we get mole in 55.5 mole. Okay, from this we get that value. Okay, so let's get back to that question. Okay, so you know that 55.5 is for water, 1 liter of water mole, and we have to calculate the mole of nitrogen. Okay, since the value of this is far more greater than this value of n, so we should ignore it, because see, if you have to add in 1000, if you have to add 0.00001, then you should ignore it, right? Same here, we ignore the value of n is far more less than 55.5, so they ignore the value of n here, and it's n by 55.5 equal x, and we get the value of x from here. Okay, now we are going to calculate, and we get the value of this n very easily. So wait, so we get the value of this n by multiply these two, and we get the value is around that much, 7.16 into 10 power minus 4 mole. But remember that we have to ask, the question is asked for millimoles only. Okay, so So to get it in millimole, we multiply it with 1000 millimole, because 1 mole equal 1000 millimole. 1 mole equal 1000 millimole, and we get it in millimole. Okay, so now we are going to that application part of Henry law. Remember that in most of the time we see question of this topic, that application of Henry law. Okay, so first question is the first application is that. Okay, so first application is that to increase the solubility of CO2 in soft drinks, so that the bottle is sealed under high pressure. So you know one thing, that whenever you open up any bottle of soft drink, then gas is suddenly goes out. Okay, so why this happen? Whenever you open up a whenever you So whenever you open up this seal, then gases suddenly ran out. Why this happen? Because in that soft drink, they want to they just want to take it for a long time, this cold drink, so they dissolve CO2 in that, so that it will remain for a long time safely. So they add CO2, but we know that if we have to add any gas in liquid, so we need to add some pressure on it. Okay, so they add some pressure and they just tightly seal that bottle. Okay, so whenever you are going to open it up, then CO2 gases suddenly move around. Okay, so that's why we need Henry law to seal the bottle. Okay, so increase the solubility of CO2 in soft drinks, we need that Henry law. Okay, and the second application is that scuba divers mean those who goes under beneath the sea. Sorry, I don't know what's the correct preposition here. Okay, scuba divers must cope with high concentration of dissolved gases while breathing air at high pressure. See, if a scuba diver goes under a sea, then what happen? They feel lots of water pressure on them. Okay, it says scuba diver, they feel lot of water pressure on them. So what happened? Solubility of gas is more in their blood, and when they return, then solubility should be decreasing. Okay, and because of this they have some pain in their blood. Okay, here we have seen that here, that scuba divers must cope with high concentration of dissolved gases while breathing air at high pressure underwater. Increase pressure, increase the solubility. Okay, in the blood, and when the divers come towards surface, when they coming back, then the pressure gradually decreases, and this releases the dissolved gases and leads to the formation of bubbles of nitrogen. And due to the formation of bubbles of nitrogen, what happened? These block capillaries and create a medical condition which known as bands. It's really very important, because most of the time there's some question about like that, what is band, explain it, something like that. Okay, and it's really very painful and dangerous to life. And the third application of this is that, and before it, to avoid this condition of band, what happened, they use some scuba divers use some air with helium there. If they use 11.7% helium and 56.2% nitrogen and 32.1% oxygen, that it will be helpful for them. Then the bubbles of nitrogen is not that much. Okay, so it's good for them. So they use that mixing of they use this mixer of gases. And the third application is that at high altitudes, partial pressure of oxygen is less. We already know that if we have to go to any hill area, then in that high altitude the pressure of oxygen is very less. Okay, so what happened, then they feel, I mean, because of this low concentration of oxygen, people 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 have some problem in breathing. Okay, so people living at high altitude or climbers, because of low oxygen causes make them very weak, and they are unable to think clearly, because in that high altitude there's very less number of oxygen, very less amount of oxygens are there. So what happened, climbers and those people who are living in that high altitude, they they don't have that much of oxygen, so they become weak and their thinking capacities also decreases. That's why it's not good for their health, and this symptom is known as anoxia. Okay, now come to the last topic of this, I mean, about we learn about that when we mix a gas in liquid, then what the effect are there. Okay, so we already learn about the effect of pressure. Now it's effect of temperature, and this thing we already learn in that, I mean, when we learn about solid in liquid, then we already understand about this effect of temperature with the help of Le Chatterjee principle. In that last video I already told about this thing, so if you don't check it till now, so you should go for it, that video first, then you should go for you should watch it, otherwise you don't understand it completely. Okay, so what we learn in that video, that when there is a endothermic reaction, then with the increase in temperature solubility is also increase, and when there is a exothermic reaction, with increase in temperature solubility is decrease. And what in case of gas in liquid solution, what happen, this reaction are exothermic. So what happen, whenever temperature is increased, then solubility is decreased. This is all about here. See that solubility of gases in liquid, that solubility of gases in liquid decreases with rise in temperature. That means because it's, since it exothermic reaction, so what happen, solubility is decreases with increase in temperature. Okay, so when dissolved, the gas molecule are present in liquid phase, and the process of dissolution can be considered similar to condensation, and heat is evolved. That means it's a exothermic reaction. Okay, we have learned the last section that dissolution process. We already learned about this equilibrium and Le Chatterjee principle. We already learned about this, and today we'll learn, you have to must know this thing, that whenever we add a gas in liquid a gas sorry whenever we add a gas in liquid, then what happen, then this process is exothermic, and that's why whenever we increase the temperature solubility is decrease. Okay, that's it all about for today's video. So we already completed that Henry law, then effect of temperature and pressure whenever we add solid in a gas, or whenever we add gas in a liquid, sorry, solid in a liquid or gas in a liquid. Already learn about these things, and in our next class we are going to learn about that vapor pressure of liquid solution. Okay, so till now we already learn about these things. So solubility of gas in a liquid, okay, this is important, where effect of pressure is more important than effect of temperature. And we already learn about this solubility of solid in a liquid, where effect of pressure if not affected that much, because they are incompressible. Solid and liquid are incompressible, so effect of pressure is not that much, but effect of temperature is more. So yeah, in effect of temperature we learn about that Le Chatterjee principle here. So yeah, that's it all for today's video. I am so study well, and if you have any question, then ask me in comment section or anywhere. Okay, okay, study well, take care a lot.